So the degeneration of the basal forebrain, the degeneration of the second source of acetylcholine release in the brain, the source that actually sends axons into the hippocampus, for example, a structure that's very important for memory, is associated with some of the cognitive losses, particularly the memory losses that you see with dementia, like Alzheimer's disease. And it turns out that the only FDA-approved drugs for treatment of cognitive decline in Alzheimer's disease are actually chemicals that inhibit, right, that interact with and prevent the normal functioning of acetylcholine esterase. Now, check back on your earlier overheads and look at your earlier notes. Acetylcholine esterase is present in the synaptic cleft, right, and an acetylcholine synapse. And it grabs onto that released acetylcholine and breaks it down. If you inhibit that process, if you inhibit it, you block the breakdown of acetylcholine, right, you end up with more acetylcholine in the cleft. And so there's more stimulation of the postsynaptic receptors in the remaining projections, from the basal forebrain into the hippocampus, and at other, potentially other cholinergic synapses in the central nervous system. So this appears to at least slow the decline, the progression of some of the memory loss in Alzheimer's. It is not a cure, however, because the underlying disease process that is destroying the basal forebrain and other regions of the brain tends to continue.